So, brief introduction. My name's Chris Roebuck. I'm from the UK, over there in Europe. Well, at least for this month. I'm a LabVIEW architect, LabVIEW champion, background in physics, team working idealist. I've got some very strong opinions on how to get teams to work better together and processes and tools that can help. And I believe that VI Analyzer is one of those, so that's why we're going to be talking about it today. I'm also a bit of a LabVIEW cheerleader. I even took my wife and kids to NI Week for their annual vacation. And they're much happier with their new father now. So, is this the right presentation for you? So if you are a team manager interested in understanding how to get the best performance out of your team, this is a good presentation. If you're just a lone developer wanting to improve the quality of your code, this is a good presentation to be in. That being said, there are tens of great presentations running right now. So if you don't think that's for you, I won't be offended. Vote with your feet. That being said, if you do leave now, you will win the opportunity to get some free swag. That's right, one lucky individual will be leaving this room today with this NI mug. More on that later. Yeah, I'm just giving away something that somebody gave me. No. So, a little bit of credit to others first. So, disclaimer. I was a CLA who didn't use VI Analyzer. In fact, I only started using it probably 4 or 5 years ago. However, I was a scripting enthusiast. I was really captivated by the fact that you could write LabVIEW code to build and write more LabVIEW code. I thought, this is just amazing. So I was inspired by people like Darren Nattinger, who created QuickDrop and VI Analyzer, amongst other things, and his quest to automate the process. And I took a look at this. I'll be mentioning this a little bit later on. I took a look at the VI Analyzer enthusiast group on ni.com. And quite frankly, I was just blown away by some of the amazing tests and quality checks that people had written themselves and made available to the community. And it kind of made me want to find out more and do that myself. So let's backtrack a little bit before we talk about the specific tool of VI Analyzer. Let's talk a little bit about software quality. What do we mean by software quality? Well, I think we can break it down into 2 areas. We can talk about functional quality and structural quality. Functional quality really gives an order of merit to how well a piece of software meets a requirement or complies with its design or the functional requirement specification. Structural quality talks about the structure of the software, its robustness, its scalability, its ability to operate in different environments. Basically, we're saying, is a piece of software fit for purpose? Low quality software costs money and time now and throughout its life, okay? That's the bit for the managers. So why does software have bugs? Well, it's written by people. People make mistakes, right? Who writes bug-free code? Anyone? So software in general is created by humans, errors in coding and syntax, misunderstanding of the required behavior. One of the things that I like to do when I work with customers is actually repeat the requirements back to them, either in a document or in a conversation, because I might have misunderstood what it is that they were asking for. That is a software bug, because the software doesn't meet their needs. Lack of understanding of environmental variables. It's great, I've written this fabulous piece of software. It's taken me a year to do it. I've written it in Windows 10, and it's going to run on a Linux system. That's a lack of understanding that's led to a software bug. Faults in the development toolchain. Of course, that doesn't happen because we all use LabVIEW, but some development tools include bugs of their own and could cause an onward problem. Things in G that I think affect quality are mainly centered in 3 areas: stylistic issues, performance issues, and what I'm going to refer to as dangerous constructs. We'll talk about each one of those in turn. But before we do, I want to refer back to a reference. Now, I've listed this as a reference in several presentations now, and a few of you have actually got back to me and said, this book's kind of transformed the way you work. It's a book called Joel on Software by Joel Spolsky. Joel Spolsky is the founder and creator of Stack Overflow. I'm sure a few of you might have looked up problems on Stack Overflow, creator of Fogbugs and the Trello application. Joel on Software is a very good book that talks about how you can improve your team, your own personal software quality. And he talks about things like, do you have a spec? Are you writing some software just off the cuff without any spec at which you're coding against? Do you have testers? Do you have people to test the code or unit tests to test the performance? Do you hold code reviews? Now, I'm sure a few of you are thinking, well, I'm a one-man band. I can't have a code review. There's nobody to review my code. Keep watching. Do you have a build system? Do you have a quick way to build your application and test it? And do you perform usability testing? That's what we're talking about where we say, did it meet the requirement? Well, one of the requirements is that you don't need a PhD to be able to operate the software. So let people use it. Let people test it. In other software languages, you'll often come across this expression, but I've never really heard it mentioned in the context of LabVIEW, and that is code linting. A code linter is a tool that analyzes the source code statically. It looks at constructs, it looks at variable declarations, coding style, indentation, comments, and it assesses it to help you remove programming bugs, errors, and dangerous constructs. So a lot of these tools exist for other programming languages like Visual Studio, C++, C#, and those tools are PCLint, ReSharper, JSHint, and they all integrate into the IDE in some degree. Well, LabVIEW's got its own linting tool. We just don't know it under that name, but it's got a linting tool called VI Analyzer, and that's what we're going to be talking about today. So VI Analyzer is a tool to perform static code analysis. It analyzes non-running code. So the code that you've written, it performs a series of inspections and tests on that to look for those style issues, those performance issues, those dangerous constructs. VI Analyzer inspects the VI properties. So you can check things like, do I have source code separated from compiled code? Do I have a VI that's accidentally set to run when open? It looks at the block diagram. So it looks at the way you've written the code, the structures, the loops, the wires, the objects, the primitives that you've put on your LabVIEW block diagram. And it looks at the front panel. Equally important is front panel layout. It also looks at, or it identifies performance issues, dangerous constructs, and those stylistic issues that I mentioned. So what is VI Analyzer? Well, I'm sure, hopefully we've got somebody from NI in the audience who can tell me which versions of LabVIEW include VI Analyzer. I'm not sure, it does change depending on version, but VI Analyzer is a toolkit for LabVIEW that you may have or not depending on which version of LabVIEW you're running, which year of LabVIEW you're running, 2015, 17, 18, 19, and which version as in LabVIEW Base, LabVIEW Professional, LabVIEW Full. But it's a toolkit that integrates into the LabVIEW environment. Now, this is a slide. I've actually taken this slide from a presentation. I think it was from Darren Nattinger that I found on the VI Analyzer Enthusiasts page. But I think it shows quite nicely the flow, the workflow of VI Analyzer. So it's initiated by going to the Tools menu in LabVIEW and selecting VI Analyzer, Analyze VIs. Yep. Then you create what's called an analysis task. So you specify, these are the files, this is the project, these are the items that I want to analyze. So it can be done by a file-by-file basis, or you can just point it at a project and say, go analyze my project and tell me how good it is. It runs, gives you some progress, and then it tells you what it found. So you can order this results dialog by VI, So it can show you each VI, what it failed for, or by failure mode. So which VIs failed because there was a wire underneath a for loop, for example. So it organizes by failure analysis or by VI. You can rank the items in terms of importance. Some things might not really be important to you, but more on that later. But some things might not be important to you, and some things you might really care about. This results window allows you to analyze those results and look at what's failed. And you can export a report. Might be useful if you want to deliver your software to a customer and you want to provide some kind of guarantee of code quality from a stylistic or performance point of view. They might need that for the audit trail, for example. So you can output those results to file. So let's see it in action. Are we playing? Hey. Okay, so I've got two VIs there in my LabVIEW project. I've got a VI with block diagram issues and a VI with front panel issues. We've all got issues. So I go Tools, VI Analyzer, and I start a new VI Analyzer task. In this case, I can analyze the current project, but I'm going to define the task step by step. So I'm going to add some items to my analysis task. I'm going to add those VIs to my VI Analyzer task. So I've specified the folder that's containing the two VIs that I want to analyze. There they are. I now can specify which tests I want to perform on those VIs, and they're grouped by block diagram, front panel, general, VI properties. So they're classified in terms of what tests are being performed, and I can deselect them as appropriate. Now I'm going to go ahead and deselect a lot of them purely for the purposes of this demo, but I'm going to test the two things that I know are wrong. So my VI that has block diagram issues has a wire running behind a structure. That's bad, don't do it. My front panel issue has got some non-transparent control labels. So they're the two tests that I'm actually going to perform. I'm going to look for transparent labels and look for wires running behind objects. I hit the Analyze button, and VI Analyzer does its magic. It's now showing me, yep, those two VIs did fail, and they did fail those tests. And if I double-click on it, it takes me to the piece of code that caused the failure. So I can see straight away where my non-transparent label is. I can see straight away where my wire running behind the object is, and I can fix it. So there's my failures. I've gone ahead and I'm now looking at the results, and I can order them by test, order them by VI. I can see their ranking. One of them is a low rank test. It's deemed as non-critical. And yeah, so that's VI Analyzer. So that's our first analysis task. Any questions on that so far? Yep.
Is there a purpose not to run all the tools?
Is speed? Yeah, I'm going to talk a little bit more about running different tests at different times during your development process. So something that I like to call scenario-based testing, but we'll come onto that a little bit more. So in terms of performance issues that you might want to be testing for, I've got 3 block diagram snippets. Yep, they're really simple and noddy, but to try and give you the idea. So I've got 3 block diagram snippets. All 3 of them work. They run, they generate an output. But from a performance perspective, they could be optimized. And VI Analyzer could look at each of these and say that could be performed better in order to optimize either speed, memory use, CPU usage, for example. So in the case of the first one, that's the same piece of code. So here I've got an empty array, I'm passing it around a loop, and I am appending data to that array. So each loop iteration, the array is increasing in size. That means that frequently, LabVIEW is having to make calls to the Windows memory manager to reallocate memory. So it's suboptimal. It would be far better to pre-allocate an array and then replace an element within that array with my new data. So that was an example of a performance issue. Another one would be prepending an array with data and then building an array. It would be far more performant to use the new conditional tunnel that's been available, I think, probably, 3 versions? One of these guys will know at the front, like the last 3 or 4 versions of LabVIEW have had the conditional tunnel. It's currently my favorite LabVIEW feature. And then on the left, using a value property node to update a control rather than using a local variable. Now, I know everybody's going to go, oh, local variables are bad. As I said, it's just an example of the types of things you could be looking for with a VI analyzer test. So that's performance issues, things that you might want to look for with VI analyzer tests. Then we've got stylistic issues. I know this is the most overused example of bad LabVIEW code, and I know Pete is probably going to say, I'm fed up of people using that as an example. Hopefully nobody here writes code like that, but somebody has at some point. Stylistic issues might be things like that. So, let's call out a few things that we can see. Wires running backwards, local variables being used to pass errors around the block diagram instead of running a wire. There's lots of issues. I'd like to be working on that project on a time and materials basis, I tell you. But in terms of stylistic checking, what we might be talking about are less obvious things. For example, using the icon view or the terminal view in an inconsistent manner. So maybe some VIs, or one developer in your team uses the icon view, another developer uses the terminal view. It looks inconsistent. You deliver that code to a customer, they're probably going to notice that. It looks inconsistent. Class accessor names, this is a favorite of mine. So people create their LabVIEW classes with really long names like National Instruments, DMM, and then various part numbers after it. Then when you create a property node for that class, it's 7 inches long, and you need one of those widescreen monitors to even be able to see it. So you could actually go ahead and programmatically check for the length of your class names and do something about it by renaming them. Labeling wires. Maybe if you've got a long wire running across a LabVIEW block diagram, you want to check that you've actually used a wire label because, you've got a busy block diagram. It might not be immediately obvious what data that wire is actually carrying. And then front panel layout. This is one of the tests to ensure that the front panel matches the connector pane. It's good programming practice to lay out your front panel in the same orientation, controls on the left, indicators on the right, as your connector pane. It won't make your VI run any faster, make the CPU usage any less, but it's a good programming practice. It leads to consistency, and it's just a good thing to do. So, potentially dangerous constructs. Okay. So this is going to be quiz time. Let's see, which one shall we? Oh, I know which one we're going to pick. Okay, so we've got 6, 7 fairly innocuous-looking pieces of code there. But each one of them, if used incorrectly, could lead to a programming bug or unexpected behavior with your software. So for example, current VI path. It returns the path to the current VI. It's great, it's really useful, except it behaves differently between source and built applications. So the path that it returns might not be the path that you expect when you've built your application into an executable. So it's potentially dangerous. Instead, I would use application directory as an alternative. So it works. You're not going to see a bug immediately while you're working with your LabVIEW source, but you might see a bug when you build your executable. So it's what I would call a dangerous construct. The file dialog express VI. Anybody know what's wrong with that or why that might cause issues? That wasn't the one I'm thinking of, but yes. Absolutely. So the express VI is really interesting in that if the user cancels that dialog, not only does it throw an error, is it error 43? Error 43 it throws, but it returns a Boolean to say that it was cancelled. So which one are you going to handle? Are you going to handle the error, or are you going to use the cancelled Boolean output? So whilst it does work, it might give you unexpected behavior depending on how you've coded for a user cancellation downstream. So it has that potential to cause danger. So VI Analyzer is something that you could use to actually test for that, to say, have I used both of those outputs, and how am I using them downstream? We'll see how to do that a little bit later on. So that's right delimited spreadsheet. Anyone using that? That's good. So right delimited spreadsheet, it has the ability to provide a runtime pop-up if no path is provided. Who's ever written a piece of software that's popped up a dialog, and that piece of code's inside a loop, and it's constantly popping up the dialog, and it's task manager, Control-Alt-Delete, kill the process? If I run that piece of code inside a loop and I don't provide a path, I'm going to get hit with that dialog box popping up. So it has the potential to be dangerous. Okay, it's prize time. Who wants a pristine LabVIEW mug? Who can tell me what's wrong? It's probably a little bit small. Okay, so there we've got the pre-launch init VI of some actor, and in that code, I've called launch actor core. Anyone? Nobody? Nobody? Oh, well. Here's what you could have won. Go on, then. One of these smart asses at the front. Go on. That's right, yeah. Nested actor. So launch root actor inside the pre-launch init. Unfortunately, launch actor waits for pre-launch init to actually finish before it launches the actor. So that code, if you've got that code somewhere, when it gets to that code, it will just hang. Yeah. But you've got a run arrow. LabVIEW thinks that compiles just fine. The rest of your code might operate correctly. There might be certain scenarios where you only see that in certain execution paths in your software. So it's one to be aware. You can collect this later from the front. So a lot of people that I've spoke to actually this week so far have talked about how their LabVIEW software communicates with databases. They store their results in a SQL database. And I've often wondered, how people do that. And this is an example of some code that I've seen recently, actually, where we've got an actual SQL command on the LabVIEW block diagram, and they've used format into string to pass the parameters into that SQL statement. Now, the diagram's a little bit small, but basically, I don't know what sanitation, is that the word? What sanitation is going on that input string prior to it hitting that function. But it's a common source of errors is to have strings being passed directly into a SQL statement. Okay? There really needs to be some kind of precondition checking of that input prior to it being passed into the string. Passed into the format into string, should I say. So unsanitized inputs into SQL statements could be bad because it depends what's on the string. If the string's got a valid input, the SQL statement's going to run just fine. If it's empty, it might not run at all, or we might get unexpected behavior on the database side. We've got a case structure with a string, in one of the cases, being passed out, and I wish I had a laser pointer, but you can see on the right-hand terminal, we've got the little white dot. Does anybody know what that means? That's right, use default if unwired. So if I don't wire every case, LabVIEW will look at the default for that particular data type. Oh, spectacular, thank you.
Points this way.
Thank you. See if I can avoid blinding anyone. Oh, look at that. There we go. There. So the little white dot that's on the terminal, that signifies that that case structure is set to use default if unwired. In the case of a string, an empty string. What's wrong with that? Well, it depends what's downstream. It depends if the downstream code can handle an empty string being passed to it. So whilst that compiles just fine. It could be dangerous depending on what code comes after it. And then finally, and this one's one of my favorites. So we've got a loop boundary, and we've got an array that's indexed, and then in this case we've got a I/O reference, a Visa reference to maybe a USB or GPIB instrument or some kind of instrument. So we've got an indexed array, and maybe that's carrying some information like voltage or frequency, and we're wanting to iterate. So this loop is iterating over whatever is that numeric array. Anybody see any potentials for danger here?
Depends on the other side. So if the array is empty, the loop will not run and will lose the value of the top wire.
Absolutely. Yeah. So, as our friend just said, if it's an empty array, the loop doesn't run, but unfortunately we lose whatever ref num was on the wire. Question?
I was supposed to say, in the past 30 days, I had that exact problem come up with the code that I inherited.
Yep.
And what was wild is you had this loop that would execute 0 times, and then the next icon after that was something to close the reference. And then the next icon after that was clear all error.
Yeah. I think the expression for that is technical debt. Yeah. So, empty ref num if array is empty. So these are the things that we want to test for. So, okay, you're all sold. There's potential danger in our LabVIEW code, stylistic, performance, dangerous constructs. You're all sold. So why don't developers use VI Analyzer? Actually, let's just do a quick show of hands. Who's using VI Analyzer regularly as part of their workflow? Okay, maybe 20%, something like that. So, why don't people use it? Well, these are some of the things I hear about. Well, I do acceptance testing anyway, so I'm going to test the thing with a big system. I'm testing my nuclear warhead. I'm going to plug it into the big test system. If there's a problem, I'll find out about it. My customer doesn't pay for style. That's one I hear quite a lot as well. They're not paying for well laid out code. They just want it to work. It fails for things I don't care about. That's a common one. Or it's disruptive to the way I work. There are just so many results to trawl through. So if we look at those, and those are all things I've genuinely heard, if we look at those, we can categorize them as noise. It gives a lot of results. There's a lot of information there. What we might call false positives. It's failed for something, but do we really care about the thing that it failed for? And then workflow. It's disruptive to the way I work. And if we think back to the slide where I showed how it runs in the video, I have to, in my VI, go to the Tools menu, select the VIs that I want to test or analyze, or the project, and then go through that configuration. It is somewhat disruptive. So I think those are the reasons why people don't use it. Noise, false positives, and workflow. So if I can give you a solution to those 3 problems, when I ask the question again next year, who's using VI Analyzer? And I won't have a presentation to give. We can sit and drink beer at that point. So we can do what's called creating a configuration. This is going to help us reduce the false positives, reduce the noise. We'll talk about the workflow a little bit later, but let's reduce the noise and the false positives by selecting what should be analyzed and how it should be analyzed. So we're selecting which tests are important to us and how those tests are going to be performed. So we can create configurations of tests, lists of tests that run. And I propose that you create different CFGs for different scenarios. So for example, if you're providing demo code to a customer that they're going to use with an evaluation board, you probably want to run a lot of tests on that because you're going to have a really bad customer experience if they run your example code and it falls over straight away or it's got a bad layout. If they see wires running under objects, they're going to be like, this guy is just haphazard and maybe this reflects the rest of his project. There are certain tests that we want to do every day. There are certain constructs that I get wrong or that I just mentally switch off and forget to check for. They're the important ones, yeah? Testing for wires, if I see a wire behind a block diagram, that's because I've just been lazy. I'm not overly concerned about that. It's the ones that I know I always miss. They're the ones that I really want to be checking every day. Pre-delivery inspection. You know, if we're shipping a system out to a customer, we probably want to run everything. High performance applications, we probably want to concentrate on things like memory usage, loop iterations, hammering the CPU and railing that. We want to make sure that the application and the code behind it is as performant as possible. Cross-platform portability. So if you have to support your application on multiple platforms, maybe your application runs on OS X or Linux, you might want to run some tests to check that you've not used ActiveX, for example, which is only going to work on Windows. Or that paths translate correctly between platforms. So you might want to have a specific test suite, a specific configuration that runs and checks for cross-platform portability. So let's have a look at creating and saving a VI Analyzer configuration. Okay, so I've got my two VIs again, my block diagram with issues and my front panel with issues. I go to VI Analyzer, so the Tools menu, VI Analyzer, Analyze VIs. I can now select which VIs I want to analyze or select a project to be analyzed. In this case, I'm going to select the project that contains those two VIs. So there they are listed, and I'm going to pick which tests I care about. In this case, I care about non-transparent front panel labels, and I care about wires under objects for this example. So I select those tests, and once I'm happy with that configuration, and you can see there's something like 97 pre-written tests. Maybe it's over 100 now, I don't know. But there's approaching 100 inbuilt tests that are provided by NI to test your code. So you can go through that list and select which ones are important for you, and then you can save that configuration. Okay, so I'm hitting save, I'm going to go and put it somewhere. Let's call it NI week demo or something, and let's save that configuration. We can choose to password protect it. Maybe you want to provide a configuration to your team and say your code must pass all of these tests, password protect it so they can't deselect them all and go, yeah, I'm good. So there's my non-transparent label test. It failed, and it asked me, do you want to see the results? Do I want to return to VI Analyzer? No. I've gone back to my project, and now I can go into VI Analyzer, analyze VIs, and this time I don't have to do all that tedious ticking of boxes and selecting of files. I can just say, let's load an existing configuration, and there it is. My VIs have been selected. The tests that I want to perform have been pre-selected. I just hit the Analyze button, and I get the result. So that's helping a little bit with that workflow problem. That's helping a little bit with the noise problem that I talked about, because we're only running the tests that we care about at that specific point in time. So there's our results, and we've still failed for the same things. We'll go and fix that in a minute. So that's our VI Analyzer configuration. Who thinks that configurations might tempt them to use it? Oh, I've only sold, another 20%. We're getting there. If we can get another 20% by the end of this presentation, I'll be happy. Yep, question.
Is the configuration always linked with the source file?
So, the config...
Yours was.
Yes.
That wouldn't work in giving it to your team.
That's right. So, the configuration from an interactive using the dialog box point of view is linked to the source files, yes. We'll see in a little while, there's an API, we'll talk about that some more, but we can actually take that configuration and pass in a different list of VIs to analyze, but performing the same tests. Yeah. So, style guidelines. Everybody's department got one of these? Everybody's? Oh, okay, so style guidelines. Who uses the one from NI that was written in 2004? Things have changed. We've moved on a little bit from then. So what I strongly suggest is that you and your team sit down and you actually think about how you want to lay out your LabVIEW code. What constructs are you going to outlaw as a team, banish? What things are you happy with? Things like separating source code from compiled code. So you're using source code control, and you've got one guy on your team who doesn't have that option ticked. So every time he changes one VI, that change propagates through his whole hierarchy, and you see 50 VIs have changed in source code control. Right? That's not helpful. So a style guide doesn't only include how you write your code, but also how you have your LabVIEW environment configured. So this is your opportunity to define your own rules and then use VI Analyzer to enforce those rules, to check that everybody's following them. So you can define your own rules for things like file names, LabVIEW options, like that particular one. You can define rules for your block diagram, things like let's not use current VI's path, let's use the application directory VI. Let's not use file dialog with both outputs wired. Let's just always use the cancelled Boolean, for example. Or let's check for error 43. Yeah? But decide as a team how you're going to do this thing. Put it in a Word document with a few screenshots. That's your style guide. It's useful to get alignment of style within teams. You know, what happens when Bob goes on holiday for 2 weeks and nobody understands how he wrote his code, yeah? And we have to wait for him to come back? Enforcement of style helps with those situations if you can get everybody coding in the same way, and then you can use VI Analyzer to police that, to check that everybody's following that guide. Okay, so I suggest a good thing to do this year, ready for NI Week 2020, go and sit down with your team, get buy-in, and write a style guide. And then you can apply your own rules by building your own VI Analyzer tests. Yeah, so we've got 96 tests that ship with VI Analyzer, but you can build your own as well. So VI Analyzer includes a tool called the test creator. It takes a template for a VI Analyzer test, asks you what you want to call it, and then you add the code that's going to perform that test. The code that you add uses VI server properties and methods to analyze the block diagram of the VI that you're analyzing. Okay, so you're looking at wires, objects, structures, and checking it to make sure it complies with the rules that you defined in that document that you wrote. And then you put your tests in this directory, and they magically appear in VI Analyzer. You can tick them in future. They're available to you to save in configurations. So if you put your tests in this directory, they become available for you and the rest of your team. You know, you can tell them all, put it in there, or you know, use some sort of package management to do that, and they can run those tests as well. So I've got a noddy example. This is not a real example, but to try and keep the block diagram a little bit simple, in this case, I've decided that I don't want to have unused array indicators on my front panel. If it's not wired to the connector pane, I don't want it there. This VI is not a user-facing VI, therefore having an unwired array indicator on the front panel is potentially a resource issue, especially if it's just a duplicate array. Why have that? It might be creating a data copy. Who knows? So I've decided that that's my rule. I'm not going to allow that. So here I've actually written some VI server code that's actually looking for that particular construct in any VI that it tests. So any VI it tests, it says, okay, is there an indicator? Is it an array? Is it on the connector pane? If it fails that condition, then it needs to be that code needs to be repaired, or it just needs to fail the test. So that's the code that I've written to look for that particular construct or that particular thing that I don't want to have in my code. Okay? So unused array indicator is the thing I'm testing for. That's the message there, and that's the code to actually test for that. And it's all standard LabVIEW code. It's VI scripting, VI server to analyze for that. So another example might be testing for non-transparent control labels. So again, I might take my panel reference, get all of the controls on the panel, and see if any of them have a label background color that is not equal to transparent. If it's not equal to transparent, then it's a failure. So I'm rolling my own tests now. I'm going looking for the things that I care about, not the 96 that are in the list from NI, but the ones that I care about. If you don't want to write your own, or before you write your own, I strongly suggest you look at the VI Analyzer enthusiast group on ni.com. I've not counted, but there are, you certainly have to scroll down the page to see them all. There are lots of tests that other people have written to test for various things, various dangerous constructs. For example, clusters or enums that are not type defs, things like that. Things that have the potential to disrupt your workflow or to cause issues with your software. So check out that as a good starting point, get some inspiration. VI Analyzer Enthusiast Group over on ni.com. So you could also choose to ignore code. So let's say that you've got a particular piece of code that you know doesn't comply with one of the rules, but you don't want that error popping up, you don't want it appearing in the report that you ship to your customer, you could choose to ignore it. There's a couple of different mechanisms. The easiest one is to use LabVIEW 2018, because in LabVIEW 2018, they introduced a feature to allow you to selectively ignore tests for particular VIs, or have certain VIs not be tested 100%. So you could upgrade to, oh, that's a terrible low-res picture. So upgrade to 2018, and that will allow you to ignore some tests, or you could just write your own code in each of your tests. In this case, I've said, okay, I'm going to create a LabVIEW bookmark called VI Analyzer Skip, and there's a VI that ships with LabVIEW that's used by the bookmark manager that returns all of the bookmarks. So I just look in that list and say, am I skipping it, yes or no? If I am, I ignore it. Okay. So selectively skipping tests if it's not important, or if you know you're acknowledging. I like the bookmark way because it's taking an acknowledgement from you. Okay, I need to put a bookmarking in order to ignore this test. It requires some interaction with the developer. Okay, so that's a good thing. It's a check that, yep, I'm going to ignore this, but I need to create a bookmark in order to do so. So you could choose to ignore some code. So VI scripting. Anything that you can do with VI scripting could be incorporated into a VI Analyzer test. Absolutely anything. VI scripting allows you to obtain a reference to the block diagram, to create objects, to move objects, to wire things together. It allows a removal of items. So what does that mean? Well, it means that we could potentially write code to fix some of the issues that we find as well. So if we've got some code, and again, it depends on your environment. If you're in a mil-aero environment, this might not be appropriate, but you might want to actually allow certain constructs to be fixed. So let's see an example where that might happen. Well, let's go back to our redundant indicators on the connector pane. So we've only wired one of them to the connector pane, so I know that if that one wasn't there, it's not going to affect downstream code, unless I've got something crazy going on with control references on the output. So I've actually written some code here that if it fails the test, if it finds that duplicate array indicator, I don't delete it because that loses a little bit of traceability. So what I do is I programmatically put that piece of that array indicator inside a diagram disable structure. So it's compiled out, but it's still there on the block diagram for reference. Again, I say it's an example just to try and give you a simpler block diagram. But if it finds that, a duplicate array indicator, it puts it inside a diagram disable structure and then programmatically adds a bookmark to my block diagram to tell me VI Analyzer repaired an unused array indicator because it failed the test. So I've got that traceability, but I've gone ahead and fixed it programmatically. So VI Analyzer not only can analyze the code, but it could actually take action in certain situations. So for example, if I got one developer who worked for me and he used non-transparent control indicators in every one of his VIs, and I say, oh, I don't like that, to actually give somebody the task of fixing that might take some time. If I add the code in my VI Analyzer test to change them back to transparent programmatically, then I just run the test, it fails, and it updates all of my code. So you've got the ability to modify and fix issues. Any questions on the modification? Yep.
How do you get to that test creator?
Okay, test creator. It's in the VI Analyzer menu. So Tools, VI Analyzer, Create New Test. Okay. So there's an API as well. Yeah. So not only do we have to go to the Tools menu and say, yeah, I want to load a configuration or I want to select the test, there's an API. So we can start to build VI Analyzer into our workflow, build it into the tools that we've already got. So let's see an example of that. So let's start playing with the VI Analyzer API. So in this example, I've got my two VIs with their block diagram issues and their front panel issues. And in this case, I don't like the workflow. I didn't like having to go to the tools menu. So let me just rewind that again. I was talking. So what I've actually done is create a project provider so that I've got a right-click option to just be able to spontaneously run a VI Analyzer test on a particular VI. So I've got a VI, I just want to test it and see if it passes without having to go through the whole process. So I've got a VI Analyzer project provider that allows me to either run a selected configuration and then store that configuration in a recent list. So there we go. So I'm going to run a specific configuration. I'm going to run my NI week demo that we created in the earlier example. And that's it. It's run. It's going to fail. Hopefully going to fail. Yep, it failed. I can double click on it and it takes me to the failure. But also notice when it's finished and we go back to the project, I've also put a little red dot over the VI in the project now to indicate that there's a VI Analyzer failure for that particular VI. So I can look at my project and say, yep, I know there's code in that I need to go and fix. Now, unfortunately, I'm lazy. I'm not going to fix it, so I'm going to add a bookmark to skip that code in future. So I could do a bookmark using a text label, but I've also created a little tool that allows me to add bookmarks to multiple VIs from the project window. So I type my bookmark in. I've got some pre-written ones down here. The one I care about is VI Analyzer skip. So it's still got the code in, but it's now got this bookmark that's been added to the block diagram telling VI Analyzer to skip this VI. I'm going to go ahead and close it. Let's run it again. So I go VI Analyzer. My NI week config is now in my recent files list, and it now skips. I had a good suggestion from somebody this morning to change that to orange to indicate it had skipped rather than green because that suggests it passed. But that's all done using the API. So you can see that being able to just right-click on a VI is far more easy than going to the tools menu and selecting a config and interacting with those dialogues. It fits my workflow a lot better. And because it has an open API, you can integrate it into however you work. So let's take that a step further. Let's think, well, we're all using source code control. Let's start checking the code before we commit it to the repository. That Joel guy again, he's got a passage in the book that says, in general, the longer you wait before fixing a bug, the costlier in time and money it is to fix. I'd go one further. A lot of people, once they've committed code that's got a fault in it, it stays committed, it stays faulty. Yeah. It's much quicker and easier to fix the fault when you find it. The sooner you find it, the better. So if you could actually make VI Analyzer run every time you commit into the repository, maybe not that whole suite of tests, but 2 or 3, 5 key tests, things that you really don't want going into the repository, you don't want being made available to the rest of the team who are using source code control, then we can use VI Analyzer to do that. So I'm not going to go into too much detail. I'll be giving a presentation later on in the week, a step-by-step guide on how to implement this. But what we use is something called a pre-commit hook that allows us to run a series of actions when we commit code to source code. And one of the things that I do is I say, OK, when I'm committing, let me get a list of all the files that have changed. What's changed? Because I only care about stuff that's changed. Let's get that list, and let's run the VI Analyzer using its API. OK? So I'm committing source code to my repository. I want to look at which VIs have changed, and then let's go ahead and analyze them. Okay? And it's just using the API. I've written minimal code to actually support that. Okay? So let's go ahead and see that in action. So this is my source code control tool. I use Tower app for Git. So I'm going to go ahead and make a change to a VI. So here's my VI. I'm going to go ahead and make a change to it. So in this case, literally, I'm just going to move something on the front panel, but it forces a resave. And now when I go back to my back to my source code control tool, I should see that one file has changed. Yep. So I'm seeing one file has changed. I'm going to go ahead and add a message that details what commit I'm making. I hit the commit button, and behind the scenes now, I've triggered VI Analyzer to go and look at that one VI and run those tests that I've selected on that VI, and it should fail. I think it's got a wire behind. Yep. Okay, so it's got the duplicate array indicators. But what my VI Analyzer test did do, we saw briefly there, if I just jump back, what my VI Analyzer test did do is it fixed the problem, and it added a comment to the block diagram telling me that it had fixed it. Question?
In this case, you didn't stop the commit, right?
I did stop the commit. Yeah, so I hit the commit button. I've got one VI has changed. It's unstaged. I hit the commit button. Sorry, I went back a bit too far. So I hit the commit button. It fails the test. It stays uncommitted. Yep. So I've not allowed that code into my repository until I've got... Now, in this case, VI Analyzer fixed the problem for me. Yeah? So VI Analyzer fixed the problem for me, but it's still not been committed. Now, I commit it with a new message, and it's been allowed in. Because VI Analyzer fixed it, that code's now acceptable. I can now put that into my source code control repository. Okay. I'm a little bit shy on time, so I'm not going to go into the server side of things. So, in summary, reviewing code increases quality. We're looking at the performance, that's code quality, how performant our code is. We're looking for bugs, that might be style, dangerous constructs. So VI Analyzer can perform your code review. So all the people that were in the room who were thinking, I don't do code reviews, I'm a one-man band, well, you've got somebody who can do the code review for you. VI Analyzer can modify your code, it can fix things, it can save you time if there's something that you're happy with VI Analyzer fixing. But it's got an API, so it can be integrated better into your workflow. So instead of having to go to the tools menu, I wrote the little project provider to be able to do it on a right click. Honestly, it wasn't a huge amount of work to do that, and it's a lot easier now being able to just right click. Please write a style guide now. So finally, further reading. If you're interested in what you've seen and you want to get started, hopefully that's the 60 or 70% of people that aren't using it right now. Have a look at improving code quality through automated code analysis. This slide will be available after NI week. If you want to take a card or talk to me afterwards, I can make it available to you more quickly. Have a look at VI Analyzer Enthusiasts community page and the blog that's run by Darren Nattinger. There's some really good community tests on there to save yourself a lot of time. If you're free later this week, I've got a couple more presentations I'm going to be giving. So I'm going to be talking about integrating LabVIEW with Jira tomorrow, 2:30. I'm going to be talking about continuous integration. So when you make changes to your code and you hit the commit, you want to see your executable built, tested. I'm going to be talking about that on Thursday, and how to build a better, faster, stronger LabVIEW team, but not looking at the technical aspects of it, again on Thursday. So if you weren't put off by this presentation, feel free to join me later on in the week.